everyone, welcome to You Can Automate. In the previous session, we have learned how to create an agent which included only single agent. In this session, we are going to learn about how to create a system which includes multiple agents to perform a single task. If you want to solve complex problem in real time, you need a multiple agent solving different problems. So in this series, we are going to learn about what is multi-agent system, how to build your own multi-agent system and using CrewAI. In this session, we are going to learn about what is multi-agent system and how it works, how agents communicates in multi-agent systems and different workflow patterns in multi-agent system, and finally we are going to learn about CrewAI. This is the tool which we are going to use it to build a multi-agent system. What is CrewAI and how it is used in building multi-agent system, that we are going to learn. First thing is multi-agent system. We need to understand what is multi-agent system and how it works. Before going to definition, let's see a real-time example how it works. Assume you are interacting with one of the travel agent system and user is asking plan a 7-day trip to Paris under some amount including flights, hotel and must visit places. This query goes to a agent, that is the coordinator agent, which analyzes the request, delegates a task, collects results and builds a final plan. What it does is it will have a connection with the different agents. One agent will do search the flights, another agent will go and search the hotel, another agent will do activity, it will find some top attractive places, and another agent will go and identify the weather, how is weather on that particular trip, and another agent is a budget planner. So all these agents will do its own task and finally it will provide the result and it will go to coordinator agent. Then this coordinator agent will provide a result. Finally, when the coordinator agent gives the result, this is how the plan looks like. Best flight, hotel options, top attractions, weather forecast, and all those details will be provided by the final coordinator agent. And all these agents share a common database or a memory that stores trip preferences, options, price, everything. This is how the real-time agent looks like. If you want to see the definition now, multi-agent system is a system where multiple intelligent agents work together to solve a complex problem. Each agent has its own role, tools, memory, knowledge. Agents communicate, collaborate and coordinate to achieve a common goal more efficient. Some of the key characteristics, which will be more autonomous, collaborative, specialized, and when you have a multi-agent system, usually you can add agents or remove agents, that is scalable and is distributed. Each task will be handled by a different agent, that is where we call it as a distributed, and goal oriented. All these systems will work towards one common goal. And what are different benefits is parallel execution, which is more faster, better handling of complex tasks, modular and easy to maintain, fault tolerant because each agent will do one task, so there is a less chances of fault. If any one agent fails also, other agents can continue. There is no dependent. Easy to scale by adding new agent. Right? What are the challenges we get in multi-agent system is coordination is the biggest challenge, and communication, this we need to handle carefully, and if there is any conflict between different agents, that need to handle differently. When there are more agents involved, there is a complexity also increases normally. So there are multiple frameworks available for building a multi-agent system. These are the few: LangGraph, CrewAI, AutoGen. From OpenAI we have a agents SDK, and from Microsoft we have a semantic kernel, and from Google we have a ADK. Whenever we are building a multi-agent system, always there will be a two ways. One is human in the loop. For example, user asks a query, it goes to agent and human will review the result whatever is coming from the agent, then it will send back to agent to refine it. When it will be used is high accuracy and reliability required. Sensitive domains like finance or healthcare, that is where human in loop is required. We cannot depend on agent completely. Without human in the loop is user asks a query, it goes to agent plans and delegates to a different agent. All the agents will execute the task, collaborate with each other, and finally it will provide the result. This is the comparison between the single agent and multi-agent system. In the single agent system, for example, if we are considering the same example of the travel agent here, one agent handles everything. It will go and search the flight, hotels, finding some attractive places, weather. All these things will be handled by single agent. But in multi-agent system, parallel and collaborative execution, all these tasks will be delegated to a different agents. Each agent will do a specific task and finally it will report to one coordinator here, and then final outcome will come here. So the real-time example here is customer support system, travel planning assistance, e-commerce recommendations, healthcare diagnosis, financial trading, software development, coding, testing, testing or docs. Next thing is the types of agent communication, how all the agents will communicate to each other. There are different patterns or different ways where each agents can communicate. First pattern is a direct agent to agent communication where agent A communicates with agent B. Second thing is a broadcast communication where there will be one agent which performs only a broadcasting, whatever the information which has that broadcast to different agents, and then agents will work on that task. One agent sends a message to all other agents. Third thing is a multicast or a group communication where there will be one agent and that sends a message to a group of agents only. One agent sends a message to a selected group of agents, sharing with the relevant agents only. Some information required only for specific agents, those information only will be shared with those group. Other agents will not have the information. Third thing is a mediated communication. There is one agent which acts as a mediator. Agent A sends a message to this mediator, then a mediator agent will send a message to B. There is no direct communication between A and the B. Blackboard communication where agent A, B and C will connect to a common shared knowledge or a data space. From there only all the information they will get it, and there is no intercommunication between the agents. Market based communication where there is one manager announces a task and agents bid to perform it. So in this approach there will be one manager agent will take the task. From manager agent the task will be distributed for different agents. When we are building multi-agent system, there is something called pattern, workflow pattern. This is very important to build a multi-agent system. Workflow pattern defines how agents collaborate, communication and complete tasks to achieve a single goal. There are 8 workflow patterns. Out of that we have picked top 3 patterns. This is commonly used when building a multi-agent system. First thing is sequential. Agents are arranged in sequence. The output of one agent becomes the input for the next agent. Tasks are completed in a step-by-step way. Assume there is a request coming from the user. There are multiple agents lined up. Here we have taken an example of content creation. User sends a request here. It goes to agent 1. Agent 1 is responsible for doing a research. Then the output of agent 1 will go to agent 2 and agent 2 is responsible for doing the analysis. Similarly for agent 3 for planning and agent 4 for final report. All these agents are responsible for doing a separate task but it executes in a sequential way. Second thing is a parallel. Multiple agents work independently at the same time. Tasks are independent and results are combined. For example, user sends a request and there are multiple agents tagged to this particular system. All these agents will trigger execution at the same time. For example, here I want to do a travel planning, right? All these agents will trigger in the same time. One agent will do search the flight, another agent will search the hotel, third agent will search about the weather, and when the execution finishes it combines results and the final output will be sent to user. So when we need to go for this parallel execution approaches when tasks are independent like travel planner. Third thing is hierarchical pattern. Here there is something called manager is involved, agent manager. A manager agent understands the goal, decomposes into a task, assigns work to a different agents, monitors the progress, reviews the results and make final decision. For example, user sends a request, it goes first to a manager agent. Manager agent will analyze the entire problem statement, it will do a planning and it will decide to which agent this particular task should be given, and it monitors the task also what is happening in each agent and it reviews the result and finally it will take the decision. Let's take an example of the travel planner here. It has a multiple agents assigned to it. One agent will do a flight search, another agent will do a hotel search, third agent will do a activity search, fourth agent will do a budget planning. When all execution completes from each agent, it comes back to a manager agent. Manager agent will review each result which is coming from the agent, then it will do analysis, then it will provide a final decision or a final output. Then the decision happens in this manager agent. This is very important concept that we need to remember. If you want to remember quickly out of these 3 patterns, sequential, step-by-step execution, one after the other. Parallel execution, do many things at once, then combine. Hierarchical, manager decides and coordinates workers. So this is about the top 3 patterns in the multi-agent system. Apart from that, we have a collaborative pattern, supervisor pattern, auction and a contract, event-driven pattern and blackboard. Now we have understood about the multi-agent system, how it works, different patterns and different communication systems, everything. To build that we need some tool. As we discussed, CrewAI is another tool tool which help us to build a multi-agent system. So let's understand a little bit about the CrewAI. CrewAI is a Python framework for creating autonomous AI agents that collaborate as a team to solve a complex task. Each agent has a specific role, goal, tools. We can build the multi-agent system without CrewAI also, but we need to write a lot of code, and all the pattern decisions, workflow management, communication patterns, we need to handle it here. But CrewAI provides us all these functionalities built in, and this is open source also. Here CrewAI is nothing but the group of agents works on a one task. User sends a query, agents collaborate, share context, use tools, complete the task together, and finally output will be provided. So when we are using CrewAI, we need to understand some of the technical terms. The first thing is an AI agent that works on a specific role, or it has specific expertise, which will have these things: a role, goal, backstory, or a context need to be provided, and different tools if we are using any of the tools, and finally the LLM, which model we are going to use. It could be any of the LLM. Second thing is a task, unit of a work assigned to an AI agent, right? So what task I need to perform, that details need to be provided in this component, that is description, expected output, and who is going to perform, agent name we need to provide here, and little context about the task also we need to provide. Third component is a crew, team of agents or a task working together. Here we need to provide the agents, all the agents involved in performing this specific task, and what are different tasks we have it, and what is the process we are following it. Here it is a execution flow or a pattern, whether it is sequential, hierarchical, a parallel, those things we need to provide here. If we are using any of the memory part, that we need to define here. Of course, if we are using hierarchical pattern, then we need to provide the manager name also, that is nothing but the manager agent. And the fourth thing is a process component. Here we need to define how these tasks are executed, that is nothing but the sequential, hierarchical, parallel, all those patterns what we have learned, that we need to define the process wise. That process is again part of the crew here, and these are the common patterns which we have learned here, and the same patterns will be used by CrewAI also. Sequential pattern, parallel pattern, hierarchical pattern, all these the same patterns, top 3 patterns which we have it here. Apart from CrewAI, we have other tools also: CrewAI, LangGraph, LangChain, AutoGen, all these tools which are available for building a multi-agent system. Again, considering the travel planner here using the CrewAI, these all the AI agents with CrewAI will include all this entire group of agents, we call it as a crew here. Here different models which are supported for CrewAI. You can use any LLM with a CrewAI. Why we need to use a CrewAI is build a role-based AI agents easily. Agents collaborate and delegate work. This is very important. Supports multiple LLMs and tools. You can use any of the tools or any of the LLMs. Flexible workflows, different workflows which are provided. All the workflows we can use it in the CrewAI. Observability, memory, and guardrails and more. Because if we are not using the CrewAI, we need to build all these things on our own. So CrewAI is providing us all these features built in. For building a multi-agent real-time systems, CrewAI is one of the better tool. And this is about the introduction of multi-agent system and different tools which we have it, different patterns. Do let me know if you have any questions. Thank you.